All right. Thanks everyone for being on time. We're gonna wait a couple minutes for more people to join before we kick off.
Francis, how long do we usually wait till it starts?
Usually people filter in by like 9:05. Yeah. We'll give everyone like another minute or two since we switched over from Zoom meetings to Zoom webinar, and then we'll do kickoff. All right, wonderful. Happy New Year to everyone. We'll be kicking off the first AIP community review of 2025 with AIP 109, which covers hiding unwanted soulbound objects. This AIP is currently still in progress, and Greg will be here to present the AIP itself, and then we'll be holding a Q&A afterwards. So, Greg, I'll let you take it away.
All right, let me figure out how to present. Uh, Give me a moment. Oh, I gotta apparently I forgot to turn on the permissions, so I gotta come back into Zoom. One sec.
Okay, no worries.
If there's a presentation without some IT issues, it wouldn't be easy. All right. Present button. Anyways,
Slideshow.
oh, this shows how many times I give slideshows. Hi everyone. I'm Greg. I engineer at Aptos Labs, and I'm here presenting a community AIP, which people have certain community members actually reach out to me about. As a follow-up to a previous AIP, I gave AIP 99. So this is AIP 109 about hiding unwanted soul-bound objects. So the original problem statement here is, I know if you guys ever interact with Web3, you end up getting a bunch of these spam NFTs or spam soul-bound objects that you basically can't get rid of. So for example, if you look at my wallet, I actually have a bunch of these random scam NFTs that link to random URLs that I don't want to see them. They're in the way of my wallet. And this is a common use case for general wallets and across all kinds of chains. So originally, we actually provided an ability for this in AIP 45, where we could get rid of the scam tokens. But we then removed it in AIP 99 rather hastily because of it was breaking some assumptions in other contracts, because it would take an object that may not be able to be moved and moving it to the address of 0x a ton of Fs, which essentially changes the assumptions that a coder might make for the actual contract that is managing the object. So this is a problem because, I don't want to see these NFTs in my account. I don't want to deal with them. And I just want to get rid of them and hide them, at least so I don't see them. And the assumption here I'm making is that people don't really care that the NFT goes away, but they do care about that they don't see it. So that's kind of the assumption I'm going to take through the rest of this presentation, that how do we make it so that they disappear and make a better UX, rather than just making sure that and making sure also at a contract level that contracts don't necessarily get messed up for developers who are building contracts with objects that would be soul-bound and might break their assumptions. Like, say a game has a soul-bound object that is specifically supposed to keep track of their stats, or Dex is keeping track of your points, and then you go and burn the points, and then you try to request it again, something else happens weird. We don't want that to happen. So the background and context I have here is, if anyone is not technical on Move, objects are essentially own groups of resources on chain that have an owner. The owner is an account or any other address. They can also be soul-bound, which essentially means that they cannot be transferred to another object, to another address, to have a different owner. There's a very common use case in Ethereum and other things for soul-bound NFTs as well. Then there are two AIPs I mentioned earlier that touched on both of these. AIP 45 outlined a process for sending objects to a burn address and adding a tombstone. This was specifically to hide specific NFTs that were sent to user and then They wanted to get rid of them without having an indexer change. And then AIP 99 removed that functionality because of some security concerns and complexity that's associated with it. And then the one last thing I want to define is tombstoning. Tombstoning essentially means you add a resource to an object or an account that identifies that it is removed or burned. So the action I ask for all of you today is to give me any feedback on the solution and see if this is the right course of action. Would love to be able to get this in sooner than later to help people deal with course of spam, and also to handle the fact that this solution that we'll go into requires possibly some work from Walt as well. So my high level summary here is that we're going to keep the scope into just worrying about soulbound objects. This also applies to non-soulbound objects, but I'm going to ignore worrying too much about that because people can still transfer objects away to a burn address specifically, and that will allow them to handle it in a normal way that doesn't require indexer work or any other process. Then also, I want to worry about the wallet UX. How do users actually interact with it? So the average user, how are they going to be able to use these NFTs and hide them from their wallet experience? The one thing I want to keep out of scope is I want to make sure that if there is a soulbound NFT that we do tombstone, I don't want to worry about whether contracts are interacting with this. So even if it is hidden, you may be able to list it on if it's a non-soulbound NFT, you could list it on a marketplace. Maybe the original contract creator can still do something to that object. I'm not going to worry about that in this case. I'm just worried about how do I make sure that the contracts hold the way that the original owner was intending for it, the original creator was intending for it to happen. And the timeline here is it probably needs about one additional week of work and to the presentation of the information that I've given today. That basically just adds extra indexer work and then possibly some interaction with other groups for the wallet integration, depending on which choice we make. And then these actual contract changes can go through at any time. They don't necessarily need the indexer work to be done. So I've kind of hinted at it a couple times, but my recommended solution is essentially we do a middle ground between AIP 45, the original implementation, and our current, 65, 45, I can't remember. The difference between that implementation and the current implementation that has no ability to burn. So what we do is we use the tombstone that actually already existed in the AIP 65. So we already have the struct for it in the resource. But instead of sending this object to a burn address, which essentially is bypassing the constraints respected by the original contract, which might say that this object is supposed to be non-transferable, we add the tombstone directly in place. And then the indexers will have to index the fact that there isn't this hidden or tombstone NFT or object, and then handle it appropriately. So that would mean maybe I don't show it in a UI, maybe I don't show it somewhere else, maybe I don't interact with it on an off-chain perspective, but an on-chain perspective, I can still interact with it. And the reason for this is, as I mentioned before, AP65 had this issue where if, let's say I make a object and it's supposed to be only at this user and they move it to the burn address, maybe it bypasses some other functionality that I might expect. Like I only allow this account to use it. Now it's moved elsewhere, it bypasses that. And it was originally built because of not having indexer work, but I think we've seen that that complexity causes us to really move this complexity to the indexer. So here are three alternative solutions I have here. Some of them are already implemented today. So the third one here is AIP 65, where we had before, but we've reverted that, and we're not going to be doing that as of AIP 99. The first one is just keep track of a list of hidden assets. You could have like a table in Move that keeps track of all your hidden assets per user, but that adds extra complexity when we already have storage slots and cost associated with the object itself. We might as well just put it directly in the objects. And then the other option is for wallets to handle them individually. I believe Petra and a couple other wallets already do this today, and this is very common in other ecosystems as well, where you can go and just like click on the NFT and say hide it, and then usually within the wallet UX it'll hide it. And then it's kind of annoying though if I have, let's say my wallet is on Petra Mobile and on Petra extension and on Pontum, each one of these I would have to manage it individually. So that is an unideal experience. So from the risk and the security standpoint, there's not much risk or security concerns because essentially it's just adding an extra resource. The extra resource is already defined, so I didn't create anything extra there. It doesn't allow transferring NFTs or changing any assumptions other than the fact if someone is assuming that they look for this resource, and then if it has the resource, they won't do something. But that would be very low concern because tombstoning is very not used right now in Aptos contracts. So as I mentioned before, some of the market analysis is other chains will either have in wallets where you can hide the NFTs specifically that are soulbound that you don't want or scams, or you can send them to someone else depending on whether it's soulbound or not. So in this case, I'm worried about the soulbound ones, so I wouldn't be able to send it to somebody else. And then some other chains allow you to burn the NFTs to regain the costs, but that does cause a little bit of the same assumption problem that I talked about was wrong with AIP 65, where I assume that this NFT exists. Let's say I have 100 NFTs that are allowed to be minted. I burn one of them. When I burn the one, now someone else can mint a new one because I didn't put in this contract that there's a hard cap of exactly 100 can be minted at one time. And I'm just counting against the number of NFTs that I have. That could cause some issues there as well. So I want to make sure that, especially like the Move contract developers here, their contract is solid and there's not extra places for them to have holes in their contract that they didn't necessarily expect from their assumptions. This is just a simple diagram that basically shows, hey, for soulbound object, I add this extra resource that says tombstone, and then an indexer would then have to index that extra resource as well. For backwards compatibility, it's fully backwards compatible because essentially it doesn't change the object at all. It just adds an extra resource. I have also made sure that the implementation that we have here is fully compatible with the previous implementation of AIP 65. So if the object is burned at and sent to 0x0, it can still be transferred back to the original user and unburned, but then future burns will not be sent to 0xFFFF. Downstream impact is wallets would have to handle this correctly, or we instead have the indexer just not send those in the queries directly to the wallets. That would make it simple enough that wallets wouldn't have to do anything, but it would be handled entirely on the indexer. And then some references to the AIP and reference implementation that does provide the ability for this safe burn correctly. And that's it for me. Francis, do we do questions now?
Yep, now I open it up for Q&A. I believe Brent has a question.
Hey, Greg. Yeah, I do. Quick question. So, how did you imagine the UI UX for allowing users to be able to mark their NFTs as tombstone? I mean, that would have to be in particular wallets, correct?
Yes. So all these solutions, I think, require basically in the wallets to have some sort of UI that allows you to hide these NFTs. Or
Yep.
in specifically this was brought up when I removed it from AIP 9 in AIP 99. There's this group, Ghosties or Ghost something on Ghost Lost, I think, on
Yep.
Aptos. There's an NFT community that specifically built a tool that lets you burn these NFTs. And then when we removed it, it broke their tool. So in this case, you might go to a website like that, go and choose the NFTs you want to hide, and then it would add that information, which will allow you to have it across all wallets at once.
Cool.
Alex?
Yeah, thanks for the presentation, Greg. So at the end, you were talking about transferring back and forth between like burn addresses like 0x0 and 0xFF. And I know that like in the Aptos framework, and since this is going to be part of the Aptos framework, like, you know, you can always basically just get a signer from wherever you want if you use the right function. So I guess I'm confused on what is preventing you from just like, you know, forging a signer and then just dumping it on one of the burn addresses as the like primary solution. Maybe there's something I'm missing about like the tombstones not being there or something.
Yeah, of course. So the way that I'll explain AIP 65. So AIP 65 essentially what it does was it added a tombstone to the object and then moved it to a burn address. In the tombstone, it had the address of the original owner, and that was specifically so you could unburn it. Okay. So the problem here is, let's say you have Akania and you have a decentralized like block list because someone's like messing with your protocol or whatever, and and you don't want them to move this soulbound NFT, you like attached it to them. What they can then do is they can burn this and move it elsewhere, and now they don't have that soulbound NFT on their account anymore because it's attached to 0x0. So now you can't use that data, the fact that you assume that it's there, and handle that accordingly. The other thing you might do is you might have, let's say, a secondary store that you don't want to be transferred, or you have a allow list on that secondary store that basically says, I don't want you to transfer any funds out of this fungible asset secondary store. When I then move it to 0x0, I can still hold on to a signer to that object and then use it elsewhere, even though it was originally blocked. It's now been sent somewhere else that I can unblock it.
Okay, got it. Yeah, that helps. I think the second one, I think maintaining the control of the signer, that part, I guess, yeah, I'm having a hard time seeing around. The first one you mentioned, where you want to like basically flag someone's account by creating an object that lists them as owner. I guess that still would require like indexing in order, because it's like reverse index from object to owner. So why, if they sent it to a burn address, can't the like logic for looking up allow list still see it? Like if I make a soulbound token that says like my owner is 0xa and don't let them participate, and they transfer that to, you know, a burn address, there'll still be an object and it'll still say 0xa is blocked. It'll just be at the burn address. But if my core logic tracks that it's there, then I guess it doesn't matter like where it's located. Is that
Yeah, I mean, so I think the important thing here is to prevent people from having to essentially special code this logic around that, because then you have to remember every time, okay, like I want to use this object and I want to say, oh yeah, I'll just make an indexer that keeps track of the owners of all these objects, and all those are blocked. Okay, but then I also have to remember that if it gets moved to this burn address, are they unblocked, yes or no? And versus maybe I might, as the creator, remove that object from them, and that could be removing the block list. So now I have to make extra logic to differentiate between those two constraints.
Got it. Okay. Yeah. I mean, I see the approach there. Thanks for that.
Yeah, it basically, I want to make it so that you don't have to, the assumptions are obvious and not more complicated than they need to be.
Sounds good. Yeah, I think it's almost like the difference between like an object-oriented first mindset versus not. So in my case, I'd probably just like stuff a bunch of addresses in a table, but I can see how for people owning a lot of different things that might not be the right approach.
Yeah, I would also probably use a table for that, but it's just an example.
Thanks.
All right. Any other additional questions from the audience? I guess Brent, your hand is still up, I imagine. Oh, cool. Yeah. Greg, do you have anything else to add on the CIP?
No, I mean, that's pretty much it. It needs like a little bit of index work to get it done, but this seemed like a decent enough approach for people. I'd love to get feedback and have any information from people about it. And also, if you are personally annoyed by a soulbound scam NFTs, let me know, because I also have a bunch in my wallet that I don't like.
All right, sounds good. If there are no additional questions, we can field all future questions in the GitHub issue, and then we can end early today.
Thank you.
Sounds good. All right, bye. Thank you all.